So we're now going to go on to the second type of area. Type 1 areas were where we were looking just between the curve and the x-axis. It could have been below, that came out negative. These ones that we're going to look at now is where you've got two curves, or two lines, or anyway, two things, and the area is squashed between those two. Or maybe it's a line and a curve, and the area is between two curves. Okay? It's between a top curve and a bottom curve. The curve might be a line, that doesn't matter. There's the top one and the bottom one. So all of the ones we're going to look at now satisfy that criteria. Okay, so this is type 2, where we're looking between two graphs. Notice that we do need the equations of both of the graphs, both the lines, for this to work. So, what we're going to do is we're going to integrate the top one minus the bottom one. Top equation minus bottom equation. Okay? That's how it's going to work. Let's be really careful because of minuses and brackets and things. From where the area starts to where the area stops. So one of the things that's really important here is to work out where the area is starting and stopping. So it's stopping there, and it's starting there. Yeah. So this is going to be where the area starts, and this is going to be where the area stops. But instead of going from the x-axis, the area, as we move across, is between these two things. This one is the top one, and we've got its equation. And this one is the bottom one, and again, we've got its equation. We do need to have both the equations there. Okay, so this is how it works. We integrate, and the top one is x squared minus 2x plus 3. No, it isn't, thank you.
It looks like the bigger equation.
It looks like it's at the top because it's written at the top of the page and it's been really stupid. So, the top one, that's why I even wrote it there. The top one is 9 minus x, and the bottom one is x squared minus 2x plus 3. And I'm starting my area at, oh, where am I starting my area? Okay, I don't know what these are. How am I going to find out what these are?
You're going to find them because they're where the two curves cross, aren't they?
Yeah, they're where they cross, yeah. So the curves cross, the other word is intersect. So how do we find out where curves cross? Simultaneous equations. Lesson 1 of the whole A-level, simultaneous equations. So we've got an easy curve, y equals 9 minus x, and we've got a more complicated curve, y equals x squared minus 2x plus 3. We're going to get the easy curve and make it say y equals, already done for us. And then we're going to substitute that in wherever it says y in the harder one. So that's going to give us 9 minus x, y equals x squared minus 2x plus 3. Put the things on the right. X, those things. So then that will become plus, that's and then, is that right?
That's right, yeah.
Thanks.
Yeah.
So, x minus 3x plus 2?
Yeah, I agree with you.
Okay, so, no?
Yes,
Yes? Okay, so x is 3 or x is minus 2?
Yeah.
Okay, so these curves cross each other either when x is 3, so that's where our area stops, or when x is minus 2, so that's when our area starts. So starting at minus 2, stopping at 3. You do quite often have to do a little bit of work to find the limits, but it would just be GCSE or C1 to do the work. Okay, so what we've got to do is minus 2 to 3. I've got 9 minus x squared, careful with the minus signs, which is the integral from minus 2 to 3 of minus x squared plus x, because of the minus x and then plus 6. Yeah, there we go. So, do you want to put it in the calculator? Do you know what I would recommend is when you put it in the calculator, actually type this in?
Okay, just make sure you made it.
Because I might have gone wrong with expanding those brackets or something like that. So I would go with typing that one in. So I will integrate.
Good luck.
Thanks, yep. So, right, minus, and then x, and then x, and then 6, and x, and the limits are minus 2 to 3. The 2 increases to a 3, turn it upside down. The 1 increases to a 2, turn it upside down. The 0 increases to a 1, turn it upside down. I think what I'm looking at is minus a third x cubed plus a half x squared plus 6x from minus 2 to 3. Have you got an answer?
I have got an answer. The calculator reckons that that is 125 over 6.
Okay. See how I get on. So I'm putting 3 in first, minus the third, 3 cubed, add a half, 3 squared, add 6 lots of 3, minus, always minus, and then the minus 2 goes in. Minus the third, minus 2 cubed, add a half, minus 2 squared, add 6 lots of minus 2, which is minus the third times 27 is minus 9.
Yeah.
Add 9 over 2, add 18,
Yeah.
minus times a minus is negative, but there's another negative, so that makes a plus. So I've got 8 over 3, and then I've got a negative squared, which is positive, so add a half, and then minus 12. No? No, good point. I've got a half times 4, which is in fact 2. Good point. Okay. What is that first bit?
Minus 9, add 9 over 2, add 18 is 27 over 2.
Okay, 27 over 2 minus,
And then 8 over 3, add 2, minus 12 is minus 22 over 3.
okay. See, those brackets were really good there because I can see I've got a plus. So I'm actually doing 27 over 2 plus 22 over 3, which is
25 over 6.
yay! Fantastic. So we had to do, I mean, actually, in a sense, this simultaneous equations, which is basically GCSE, was almost the hardest bit, really.
Yeah.
The integration is C1 until you put the numbers in, but the calculator checks it for you. So the main thing to remember is this integral at the top minus the bottom.
And getting all the right way around.
Yes, yes. So I'm going to actually make a note to myself again which one's top. This one's on the top. That one is top. And this one, I have got the equation of this line, of course. It's just y is 3 over 2.
And that's your bottom.
And that's my bottom one. It's a very simple equation, but I have got the equation just by looking at it. Y equals 3 over 2. Okay, integral. Top minus bottom. Agree with that?
I do.
Area is, oh dear, I don't know where I'm starting and stopping. Again, I think I'll let you do that job.
Oh, thanks.
That's all right. So where's the area gonna start and stop?
It's going to
It's
start and stop when
intersecting it.
they
It's, yeah,
intersect
yeah,
each
it's
other
intersecting.
again. So we've got a simple equation to a harder equation. The first one already says equal to y, so we're good on that.
Yeah, so
So
sub
it's
that in the other one.
So that there going in there. So
Yeah.
3 over 2 equals 4x. You're horrible. Could you not?
Double everything?
Minus 4x squared plus 8x.
Maybe put everything on the left?
4x squared minus 8x plus 3, 0. Right.
Does it?
I think this is going to not. No.
No, hang on. We can do that thing again that I've just learned.
Oh, hang on. Yeah, we can, can't we?
Yeah.
I know it.
4, 12,
X
3,
squared
4,
minus. Oh,
So
no,
6 and 2.
wait. No, you don't want 6 and 2.
Yeah.
You do 9 and.
Yeah, but what I was doing is, if you take these two,
Yeah.
you want it to sum. No, you want it to times to 12. 4 times 3 is 12.
Yeah.
And add to 8, which is in the middle. And the thing that times this to 12 and adds to 8 is 6 and 2. And then what you do is, I only just learned this,
Well, I don't
is, is this one.
You're going to make me want to work it out myself now.
And then I think I'm not claiming this is going to work, I'm just claiming it might work. Yeah, look. This is going to work. That's actually quite difficult, isn't it?
I said I like that little term thing. It's just it is hard if you don't know the method.
Yeah.
Yeah.
I think that is a really hard one to factorise.
Yeah, it's not easy.
Yeah. So have we got our top and bottom now?
Actually, you should just study this now.
Agree?
Yeah.
Okay. So we're going from a half to 3 over 2. Yeah?
Yeah.
Okay. To punish me for not doing that myself, I will now do the integral myself. But actually, can you check, please, that I don't go wrong? Because there's fractions and all sorts here. I can't see this going wrong. Okay, so integrating. That, and then that, and then that. No plus c, but we do need to keep hold of these limits. Increase the 2 to a 3, stick it upside down. Increase the 1 to a 2, stick it upside down. Increase the 0 to a 1, stick it upside down. Giving us minus 2/3 x cubed. Add 2x squared minus 3 over 2x from a half to 3 over 2. Have we got an answer for this yet? Okay. Right, I'll see if I can beat you. I won't see that actually because I can't. There's too
Yeah,
many.
but you know I'm really slow at this.
But these are fractions and okay, there's my top limit in minus. Oh my goodness.
You do this to yourself sometimes. Okay, I've got an answer.
See, you won. Okay. If I get this right, I'm going to be amazed. Right, 3 times 3 times 3 is 27. 27 times 2 is 54. So minus 54 over 6. Add.
No.
No?
No.
No.
Cube.
No, I did that deliberately to just... yes. I did that deliberately to demonstrate what can go wrong. Here, this is... Okay, slower. Minus 2/3, then it's 27 over 8.
It is.
Because you have to cube the top and the bottom. I knew that. Plus, okay, so it's 9 over 4 times 2.
Yeah.
And then it's 9 over 4.
Yeah.
Minus. Okay, 1 times 1 times 1 is 1, so minus 2 on the top. 8 times 3 is 24.
Yep.
Add 1 over 4 times 2.
Yeah.
Minus 3/4. Right. Okay, so it's minus 54 over 24. Add 9 over 4. To be honest, at this stage, I could just use a calculator, couldn't I?
Where's the 18 over 4?
I did these two together.
Oh, right, okay.
Is that right?
Yeah, that's fine.
Okay. And then I've got minus 2 over 24 minus 1/4.
Yeah.
Okay. I need a calculator. No, yes, I need a calculator. Yes.
Well, the answer it reckons is a third, which
Okay.
seems like a very simple answer for all that work. But there you
Right, okay.
go. Minus 54 over 24 plus 9 over 4 is 0.
Is it?
Yeah, actually, yeah, because you times that by 6 times that by 6.
Oh, yeah. Good point. Okay.
Whew. Okay, and then minus 2 over 24 minus 1/4 is minus 1/3.
Hooray.
Which
So minus makes positive, which is good. Excellent. We are getting there. Right. Do you want to take this one on?
Right, let's do this. So we are going from 0 to whatever this point is here. We don't know yet. And we're going to have to find that by seeing where those two lines intersect each other. So y equals 2x and y equals 6x minus x squared. Now you've got y equals on both sides. So 2x is 6x minus x squared. Sorry. Which, if my brain would function, minus 4x is 0?
Yeah.
Yes.
Yes, I agree with that.
So x minus 4 is 0, so x is 0, which we've got, and x is 4, which must be this point here. Right, top curve is the curvy one, which is this equation, and then the bottom curve is bottom line is this one, which is that equation. So we're going to do the integral between 0 and 4 of the top minus the bottom dx, which is the integral of 6x minus x squared minus, probably worth sticking it all in brackets, 2x dx, which is integral between 0 and 4 of 6x minus x squared minus 2x dx. One more step, just so it's nice and neat. 4x minus x squared dx. Right, now I can actually integrate it. That looks like an awfully lot of work before I've even gotten to the integration.
Yeah, it is, yeah. Sometimes in the exam it will break it up for you. So part A, where do they intersect? Part B, integrate.
That would be nice. Right, 1 goes to 2, so that changes, and 2 goes to 3, so that becomes the third.
Right?
Which is...
To be honest, this one looks less messy than the last ones we've been doing.
It really did, didn't it? X to the 3 between 4 and 0.
Yeah.
Right. So I know what my last bracket's going to be. You really need to
Noticing
do
the
this
pattern,
one.
noticing.
So this one is going to be 2 4 in squared minus 1/3.
What I'm gonna do is type in this, yeah?
Yeah.
So I'll put that in the calculator and see what the calculator says. Integral.
Meanwhile, I'm going to work this one out.
Yeah.
And I'm going to do it. 4 squared is 1632 minus 4 cubed 64.
4, 16, 64, yeah.
Right, that is 96 over 3 minus 64 over 3.
Okay, I've got an answer
Which is,
for this from the calculator.
and I think I'm going to do the same.
Oh yeah, brilliant. Fantastic. Excellent. So big thing here, if you've got two curves and your area that you're trying to find is in between the two curves, then you look at which one is the top one, and you integrate the top one in brackets, because you're being really careful with minus signs, minus, and then whichever one is the bottom one, and your limits on that are going to be where the area starts to where the area stops, and those things are going to be found using simultaneous equations, because it's where one graph crosses another graph.